Hi students, today I am going to explain a couple of problems from chapter 3. Chapter 3 is basically discusses interest and equivalence, right? Most of us are familiar with interest. When we put money in the bank, in the savings account, or if we make fixed deposit, we get interest on that deposit, right? So the chapter 3 goes over the different types of interests, equivalence, and the related calculations. Okay, so there are two simple problems I am going to explain that will give you a basic idea of chapter 3. So let's first focus on problem number 1. Let's read the problem first. Mr. Wood opens a savings account by depositing $2,000. The account pays 2% simple interest. After 3 years, Mr. Wood makes another deposit, this time for $4,000. What will be the amount in the account when Mr. Wood withdraws money 8 years after the first deposit? So let's see what the information that is given to us is the first deposit was for $2,000, right? And 3 years after first deposit, the second deposit was for $4,000, and the money was in the bank for 8 years. The first deposit of $2,000 was in the savings account for 8 years, and the second deposit, which was deposited 3 years after the first deposit, was in the savings account for 5 years, right? And during this period, the bank consistently gave 2% simple interest. So we need to based on this information, we need to calculate after 8 years what is the value of the two deposits, what is the current sum of money after 8 years in that particular savings account. Right. Before we solve this problem, I would like to explain you one more thing. As you can see here in this problem, it says simple interest. So there are, as many of you may be aware, there are two different types of interests. One is called simple interest and another one is called compound interest. What is the difference between the two? In the simple interest, for example, if the interest that you get in year 1, it doesn't get reinvested. So the interest doesn't get, for example, if for example $2,000, right, invested in year 1. So after first year, based on 2% interest rate, 2,000 multiplied by 2%, right? So that would be $40. I would believe $40 interest that Mr. Wood will get after first year will not get reinvested. So he will not earn interest on interest. So that is simple interest. Compound interest is exactly opposite of that. In compound interest, what will happen is the $2,000 that was deposited in year 1, and after the first year, the interest $40 which got added, that interest gets reinvested. So from second year onwards, Mr. Wood will start getting. So at the end of year 1, Mr. Wood will have $2,040 in his account, and he will start getting interest on the $2,040 in case of compound interest. In case of simple interest, he will get interest only on his initial deposit, that is $2,000. So that's a big difference. Compound interest is better because that increases your the value of your initial deposit based on which the interest is calculated, right? So in the problem statement, always if you are working on this type of problem, you need to first make sure what kind of interest is mentioned. If nothing is mentioned, then by default you can assume that the interest is compound interest. Okay, if nothing is given in the problem statement, that means the interest is compound interest. In case of a simple interest, it will be explicitly mentioned in the problem statement, like how it is mentioned here. right? Now let's see. So now we need to solve this problem. So for simple interest, there is a formula to calculate the simple interest. One more thing I want to say is, if now onwards you will see these letters F. When you see F, that indicates future value. Okay, F is for future value. P, if you see P, that means P means present worth, and if you see A, that means equivalent annual payment, or maybe equivalent annual cash flows. So you will, these three letters F, P and A, you will consistently see them during different problems. F indicates future value, P indicates present worth, and A is for equivalent annual payments, right? So sometimes P is given and you will be asked to calculate F. Sometimes F is given, you will be asked to calculate P. So if future value is given, you will be asked to calculate the present worth. Sometimes present worth is given, you will be asked to calculate equivalent annual cash flow or equivalent annual payment. So you need to be familiar with these three letters here and what they indicate, right? So now that's that. So now let's focus on the formula or the calculation for the simple interest in this case, right? F meaning future value, right? Future, we need to find out future value. Future value, that means value of the deposit after 8 years, right? So F is equal to P. P means current value or present worth. So in this case, P is $2,000. P is $2,000 plus, so future value of Mr. Wood's deposit would be its present worth P plus P multiplied by I. I is for interest rate. Okay, I is for interest rate. In this case, interest rate is 2%. So P multiplied by I multiplied by N. N is for number of years. So this term P multiplied by I multiplied by N is the interest, and P is the existing value or the current value of the deposit, right? So now we can start putting numbers in this equation to get our answer. So F is equal to 2000. First deposit, as you can see, was $2,000, right? So 2000 there plus 2000 P again, 2000 multiplied by I, which is 2%. That means 2 divided by 100, which is 0.02, multiplied by 8, number of years, right? First deposit was in the bank for 8 years, so we need to multiply by 8. As you can see, initial deposit remains in the account for full 8 years. So that is that. So that's just one part of it. Then the second part is, after 3 years, Mr. Wood made another deposit of $4,000. So we need to also take that into consideration. So this is first part plus 4,000, right? 4,000 plus 4,000 meaning the another second deposit, plus we need to find out the interest on the second deposit, which is 4,000 multiplied by I, interest rate. That didn't change, so there is 0.02. But the second deposit was in the bank only for 5 years, because it was deposited 3 years after the first deposit, right? So it was there for 5 years. So N is 5 in this case. So now you calculate these, the first term, calculate the second term, and then if you add these two terms, you will get F is $6,720. That answer you will get. So that's our final answer, considering that the bank was giving simple interest. So that simple interests are rare. Most of the time interest do get reinvested, and you get interest on interest. So in the bank, like if you have any deposit in the bank, most of the time, I mean almost all the time, the interest that you are getting is compound interest. Okay, So how can we, if it would have been, it would have been 2% compound interest, how can we solve this problem? So that takes us to the next problem. Let's read this problem first. Mr. Ray deposited 200,000 in the Old and Third National Bank. If the bank pays 8% interest, how much will he have in the account at the end of 10 years? Okay, now this is the very similar question, except it says the bank pays 8% interest. So the problem statement does not mention whether it is a simple interest or compound interest, and when it does not mention, we are by default supposed to consider it as a compound interest problem, right? So now again the letters that we looked at in the first problem, they remain the same. We need to calculate f value, we need to calculate future value, right? Which will be equal to, in this case the formula changes. Okay, for f, if you want to calculate f, you use p value, which is $200,000, p value multiplied by f given p, in the bracket f given p comma 8% comma 10. So what is this term here? That means f given p is a factor that we need to find out, and we use that factor, we multiply p, we multiply the present worth by that f given p factor, that will give us f value. Okay, but how to find out f given p factor? That factor depends on interest rate, number of years. So in this case interest rate is 8% and number of years is 10, right? So at the back of in the back of your book, you will see, if you go to the back of your book, you will see appendix B, compound interest tables. So we have tables, we can go through those tables to find out this f given p factor. Now how to look these tables, so I will explain you here. So you can see some formulas are mentioned here. F given p indicates if p value is given, you need to find out f. P given f, so there are different factors, f given p factor, p given f factor, and so on and so forth. As we progress further in future chapters, we will go over these other terms, but for this problem particularly, we are only interested in f given p, right? So let's scroll through tables. These tables are compound interest tables. So you can see compound interest factors are given there in the tables, and you will see first table is for 1/4% interest rate, 0.25% interest rate. So should we be using that table? No, because the interest rate given to us is 8%. So we need to find out the table that has 8% interest rate. So we scroll down, 0.5%, as you can see, 3/4%, 1%. This one has 1 and 1/4%, and so on and so forth. If you scroll down, 2%, 3%. So we go all the way to find 8% interest rate table. Here we go, right? So now 8% interest rate table is there. There are rows and there are columns, okay, in the table. So the first column is gives n, that means number of years. In our case, how many number of years we have? 10 years. The deposit was there for 10 years in the bank, right? So 10 years. That means we need to look for n is equal to 10 year. So this is the row that we are interested in. Okay. So now there are different information in different columns that is given to us, and we will use different information at different time. For example, first column is f given p, right? Second column is p given f. Third column is a given f. These are all factors. We are interested in f given p. As you can see, p is given. We are interested to know f given p factor, so that we use that factor to multiply p to get the future value, right? So let's see, f given p and n is 10 years, so that number is 2.159. So that is here 2.159 at 8%, f given p at 8% and number of years 10. So 2.159, if you do the multiplication, you get f value, future value is $431,800. That's the answer for the second problem. So I guess based on these two problems, now you do understand the difference between simple interest and compound interest, and you understand the compound interest tables at the end of the back of your book, and you can find out different factors from those tables. Okay, so that's it for this lecture.